Check this out right here. Right here we have the equation of a plane and the plane drawn itself. And we're going to take the scrub tool, we're going to scrub these coefficients, and look at this. Now the plane is perfectly vertical, but now it's tilted a little bit. And that purple vector n right there is actually said to be the normal vector of that plane. That vector n is said to be orthogonal, or in this case perpendicular to the plane itself. Recall, two vectors in 3 space are orthogonal if their dot product is 0, and as a consequence, those vectors will be perpendicular to each other if they're graphed with the same initial point. Well, right here, notice that this segment right here and that vector n are perpendicular. Doesn't matter how I align, doesn't matter how what I make those parameters there. Those the x coefficient, y coefficient, and z coefficient, those coefficients will always form a vector that is normal or orthogonal or perpendicular to the plane itself. Check it out right here. Here we have the vector 5, 2, 4, and up here we have the vector x, y, z. And if we actually take that vector, look at this, take those two vectors, if we actually take the dot product of those two vectors right there, the dot product of that vector x, y, z and 5, 2, 4 is 0 because the vectors are orthogonal, they are perpendicular. So therefore, by definition of dot product, we get that equation right there. And that's why the equation of a plane is what it is.